Good day, folks. Welcome to my YouTube channel. If you're new here, please don't forget to subscribe, like all my videos, watch them till the end. Don't skip the ads. Welcome. Today we are doing the Newton's first law. This is Newton's application. I'm gonna look at the first. This is question 4. It's a grade 11 and 12 revision. Let's cut the chase. It is a box with a mass of 50 kgs pulled with a force of 95 newtons at an angle of 40 degrees to the horizontal. The box moves with constant velocity. That's a very important statement. When an object moves at constant velocity, that's Newton's first law. That means the acceleration is 0 and the F net is equal to 0. Very important, the forces are balanced. Now if you look at this object, it's pulled at an angle. If it's pulled at an angle, you have a horizontal component there, which is f of x, and then you have a y component there, which is fy. You can draw it like that as well, right? Now what is important, when an object is pulled at an angle, the normal force is not equal to gravitational force only. It's equal to gravitational force minus the vertical component, which is the Fy. Now guys, I'm not gonna do question 4.1 and 4.2, its definition. I'm gonna go straight to 4.3. Right guys, now it says calculate the magnitude of the horizontal applied force, which is 4.3. So it's fx is equal to f cos theta, and then the force is 95 cos what, the angle is 40, and then the answer, it will be when you punch that in the calculator, 95 cos 40 is going to be 72,77 newtons, and the fx is going to the right. As you can see there, it's going to the right. Now 4.4, it says calculate the magnitude of the normal force. 4.4, as I've mentioned, the normal force is equal to fg minus fy, which is the mg minus f sine theta, right? Our mass is 50 times 9.8, 50 times 9.8, and then the f is 95 sine 40 degrees. So if you punch that in the calculator, you'll get 428,94 newtons. And then the normal force is the force that is perpendicular to the surface, right? And so there's an fk there. The normal force is the force that is perpendicular to the surface, so the answer, the direction, it will be perpendicular to the surface, right? The 4.5, it says calculate the magnitude of the frictional force. The magnitude of the frictional force in 4.5, it's going to be fk is equal to mu k times normal force, right? So if you use that, do we have the mu k there? No, we don't have the mu k, so we are looking for a frictional force, so we have two unknowns, so we can't use that formula. So let's try this one that says f net is equal to ma. We know the acceleration is equal to 0 because it moves at constant velocity, so it's going to be 0 there. And then the net forces, the forces that are acting there, we have a horizontal component and the fk there. They're going opposite direction. We're going to choose right as positive. That means the fk is going to be negative and the fx is going to be positive. So fk is going to be equal to fx if we take that to that side, so they are equal. So if we calculate, so we already calculated the fx there, so the fk is equal to 72,77 newtons to the left. Guys, when the forces are balanced, when an object moves at constant velocity, that means the forces are balanced. These two forces are equal. These parallel forces are equal there. Now 4.6, it says, will the coefficient of kinetic friction, which is the mu k, change if the angle between the applied and the horizontal change? Write down the only yes or no. So the answer there is no. So they do not want, it's not going to change. The mu k is not going to change. If, let's say, if they ask the reason, you will say mu k is independent to the angle, right? So the mu k does not depend on the angle, but the type of surface. It depends on the type of surface, right? It depends on the types of surface, on the type of material that is used on the surface, right? That's the end of the question, guys. I hope you understand. Cheers. Bye.